All right, let's talk about tangent lines. Now, remember, if you have a true tangent line, it's going to come outside the circle and it's only going to touch the circle one time. When it does, it should be perpendicular with the radius or diameter at the point of tangency. So if AB is a tangent line, it'll be perpendicular to this diameter AS at the point of tangency, which is A, which will make a right angle. And once it makes a right angle, you can see we have a right triangle. Now, this being a radius, to find the diameter, we'll do 4.8 times 2, which is 9 6/10. Be very careful about these where it only shows the half, okay? Now, if this is a true tangent line, then the Pythagorean theorem should work beautifully. So we'll take our leg, 9 6/10, and we'll square it. We'll take our other leg, 7 2/10, and square it, and it should equal our hypotenuse, which is going to be 12 squared. All right, so let's go to our trusty calculator. Okay, and we're going to put in 9 6/10 squared plus 7 2/10 squared, and that's going to give us 144 for this left side. Now, if we square this side, 12 times 12 is 144. Do you see how the Pythagorean theorem works out beautifully? So what does that tell me about AB? AB is a tangent line. So we can say yes, exclamation. It is a tangent line. Now, let's look at number 20. Okay, if AB is a tangent line, it will be perpendicular to our radius AC at the point of tangency, which is A. So once again, we have one of these partial lengths. So we've got 6 8/10. Well, if AC is my radius of 11 2/10, then C to the circle here also is a radius at 11 2/10. So if I take these two and add them together, 6 8/10 plus 11 2/10, let's see, that's going to give me 18.0, which is 18. So that's going to be my hypotenuse, isn't it? So if I do A squared plus B squared equals C squared, it should balance out if AB is a true tangent line. So let's go to our trusty calculator once again, and we'll do 11 2, put too many decimals in there, 11 2/10 squared plus 15 squared. And that's going to give me 350 44/100 for the left side. Now, if we go to the right side, we have 18 squared, and we know that is not going to yield a decimal. So do these two match? That is a big old no. Okay, since the Pythagorean theorem doesn't work out, then that means that AB cannot be a tangent line. Okay, now looking at number 21, it tells us in the directions that segments that appear to be tangents are tangents. Wow, we're going to solve for x. So here, this appears to be a tangent, doesn't it? Which is going to be length x. That means it's going to be perpendicular with the radius. So we got 8, we got 11 here. Now if this is 8, then this is 8. So 8 plus 11 is 19 for our hypotenuse. So to find x, let's do a squared plus b squared equals c squared. 8 squared we know to be 64. 19 squared is 361. Let's subtract 64 from both sides, and that's going to give us 297. Oh, you can't see it, sorry. Now let's take the square root of both sides. So the square root of 297, okay, you see on my calculator I have 17.23. I'm going to go ahead and round to 2 decimal places to get 17 23/100. So x is equal to 17 23/100. And that's going to be the length of my tangent line. Okay, let's look at number 22. So from the center to the side is my radius of 3. The center to this side is my radius of 3. So this whole thing has a length of 3 plus 3, or 6. Now, it appears that this 3 2/10 is my tangent line, so it should be perpendicular with my radius and diameter at the point of tangency. So this gives me, once again, a right triangle. So my leg, 3 2/10 squared, plus my other leg, which is 6 squared, should equal my hypotenuse, which is x squared. Okay, so if we plug this into our trusty calculator, we have 3 2/10 squared plus 6 squared, which is 36. That's going to give me 46 24/100. So to solve for x, I'm going to take the square root, and that'll give me 6 8/10. So x is equal to 6 8/10. Okay, now 6 8/10 or x, this is not a tangent line, because you'll see on this particular example, you can see that it touches the circle twice. This is a secant line. All right, looking at number 23, if DE and EF are tangent to circle G, find EF. Now, we have a property for tangent lines that if two tangent lines connect at the same external point, then those two tangent lines are congruent. So that means that 10x minus 19 is equal to 4x plus 23. Let's subtract that 4x from both sides, and that'll give me 6x minus 19 is equal to 23. Add 19 to both sides, and we'll get 6x is 42. So as we divide by 6, we'll get x equals 7. But it's not asking me for x, is it? It says to find EF. So EF is 10x, x is 7, minus 19, or 70 minus 19. So EF is 51 units. And finally, find the perimeter. So, if these two are tangents, and this third one is a tangent, when they meet up here, I know that this side, 5 9/10, is equal to this side, which is 5 9/10. If this whole thing is 27 4/10, I can take my 27 4/10 and subtract my 5 9/10 to get 21 5/10. So these two tangents meet here. So if this is 21.5, 21 5/10, so is this one. And if this is 12 2/10, then this is 12 2/10. So to find the perimeter, we have to add up all the sides. So we have to take our two 21 5/10 and add them together. Okay, we'll take our two 5 9/10 and add those together. And then we'll take our two 12 2/10 and add those together. And we can just multiply these by 2. I don't know why I'm simply adding all these together. I just feel like adding, I guess. Okay, add everything up. And we get a perimeter of 79 2/10.